futuristic advancement in mechanical and civil engineering. Before starting the presentation, I would like to welcome our chairs. It's a great pleasure and honor to welcome Dr. Pradeep B, Assistant Professor and HOD in Mechanical Engineering, Government Engineering College, Kozhikode. He has about 23 years of teaching experience and 3 years of industrial experience. His achievements are patent received for invention of new induction system for two-stroke engines, Bhagyalakshmi Krishna Iyengar Award for Best Project at IIT Madras. He has published several papers in reputed journals and conferences. His areas of interest include IC engines, refrigeration and air conditioning, heat transfer, CFD, solar energy technologies, and thermal engineering. On behalf of our college, I welcome you, sir.
Thank you, Ashwin, sir. Thank you.
Next, I welcome Professor Anshal Jubi, Assistant Professor in Mechanical Engineering, Government Engineering College, Kozhikode. He has completed BTech in Mechanical Engineering from GEC Kozhikode and MTech in Thermal Engineering from NIT Calicut. He has more than 4 years of industrial experience and more than 6 years of teaching experience. His areas of interest include CFD, heat transfer, computational and numerical methods, turbo modeling and simulations, control system and robotics. On the behalf of our college, I welcome you, sir. Now I welcome Associate Professor Ebisar to speak a few words.
Thank you, sir. Thank you, Ashwin, sir, for the wonderful address. I wanted to add a few words. That's why I have requested, Ashwin, sir, to grant me few minutes to introduce, to tell a few words about the chairs, external chairs today. Pradeep, sir, and myself were working together in MES Engineering for college for a long time, and we are thick friends. I'm so happy that Pradeep sir has accepted this invitation and is available here. And he is, as Ashwin sir has already told, he is a noted academician, and he is presently the head of the Department of Mechanical Engineering in Mechanical Engineering, head of Mechanical Engineering in DEC Calicut. And also, Anshal sir, he is belonging to this college only. He was the person who was responsible for this particular conference. FAMCE 2021, we are sitting together. It is having a previous version of this. The previous version of this was FAMCE FAME 2016. That's the first edition of this. And actually, Anshal sir was the person who has made it possible, who has made this particular thing possible. And I'm very happy that Ashwin sir has come back for the second edition as a chair. And we are very happy to welcome you back. Both Pradeep sir and Ashwin sir, we are very happy to welcome you. Anshal sir, Pradeep sir and Anshal sir, we are very happy to welcome you back to the campus.
Thank you.
And also Susuni sir, we are happy that we are very happy that you are the second PhD holder, third PhD holder in the department. Very happy that you have recently achieved your doctorate. So I'm also happy to welcome you also to this particular chair. Thank you once again.
Thank you.
Let's enjoy the papers. Okay then, thank you. Yeah.
Okay, thank you, sir.
Next, I welcome Dr. Sudesh N, Assistant Professor in Mechanical Engineering, College of Engineering, Talasheri. He has more than 4 years industry experience and more than 15 years of teaching experience. His area of specialization is manufacturing. On the behalf of our college, I welcome you, sir. Then I welcome all the participants and faculty to this event. Thank you. Now
Thank you, sir.
We are about to start the presentation session. Now I welcome Vaishnav Vidyadharan of Government College of Engineering, Kannur, to present the topic.
Hello, sir. Am I audible?
Yes.
Okay, sir. Shall I start presenting?
Yes.
Yes. Yes, Vaishnav.
Good morning, all. I am Vaishnav Vidyadharan. I am a PG student at Government College of Engineering, Kannur. And this is my topic, a novel memetic algorithm for solving flow-shop problem with sequence-dependent setup time. So these are the contents of the presentation. So as an introduction, we know that scheduling is means allocation of resources over a given time period to minimize objectives like make span, tardiness, energy consumption, etc. There are different types of scheduling problem: job shop scheduling, flow shop, open shop, parallel machine scheduling, etc. And among the productive systems in industries, 70% of them follow flow shop configuration. Flow shop scheduling, in flow shop scheduling, n jobs are processed in m machines in the same order. Also, flow shop scheduling problems are combinatorial in nature with NP-hard complexity. So there are different types of flow shop: flexible flow shop, blocking flow shop. Flow shops operating in sequence-dependent setup time environment. It's a realistic variation of flow shop scheduling problem, in which the setup time of each job on each machine depends on its immediate predecessor on the same machine. So this is the literature survey. So flow shop scheduling problems can be solved using different types of method: exact method, heuristic methods, and meta-heuristic methods. So exact methods such as branch and bound, dynamic programming, enumeration, etc., were used to solve such problems. So it was found that only small size problems were successful by solving using exact methods. So a lot of heuristic methods such as NEH, Johnson's algorithm, memory-based heuristics, etc., was used to solve this problem. So it was understood that heuristics are a fast method, but they can easily trapped in the local optima. So they're used to produce a solution of good quality and less computational effort, or to prepare a seed sequence for meta-heuristic methods. So memetic algorithm, there are different types of memetic algorithm: genetic algorithm, simulated annealing, veil optimization algorithm, etc. Are some of the meta-heuristic methods used to solve flow shop scheduling problem for minimizing different objectives. So meta-heuristic methods are, although they are slower than the heuristic methods, they can easily escape. They can escape from the local optima, and thus generate high quality solutions. So based on the literature survey, around 60% of the recent works have used meta-heuristic methods for solving flow shop scheduling problem. It is due to the inherent complexity of the problem. And the review shows that the exact methodologies are limited to small size problems. And for practical size problems, meta-heuristics are the preferred choice for the most of the researchers. Also, make span is the most commonly selected parameter due to the significance of completion time in manufacturing situations. So the gap in the literature is that flow shops generally have setup times which are usually sequence dependent in nature. But due to the complexity of the problem, setup times are usually ignored while solving the problem. So these variety of heuristic and meta-heuristic methods can also be applied to solve flow shop scheduling problem with SDST or other variants of the flow shop. So in this work, a novel method proposed by the author Muhammad Kurdi in his paper, it is applied to solve SDST flow shop scheduling problem. So this author in his paper proposed a novel method, a novel memetic algorithm for solving normal flow shop scheduling problem by minimizing make span. It uses an NEH-based semi-constructive crossover and mutation operation. And in that paper, it is compared with 14 well-known algorithms, and it outperforms all except 3 iterative greedy algorithms. So in this work, this algorithm is used for solving SDST flow shop scheduling problem. So these are the objectives of the work. First, to develop a MATLAB code for this algorithm, and to conduct experimentation on 120 tailored benchmark problems, and to compare the make-span results with that of the results of an existing algorithm, that is genetic algorithm. So the methodology is a memetic algorithm which with an NEH-based reconstructive evaluation operators for solving flow shop scheduling problem with SDST in MATLAB, and then test the code with well-known tailored benchmark instances for detailed analysis. So this is the procedure of the algorithm. So these are the steps. First is the parameter initialization, then generate initial population with the population size of 100 with one sequence based on NH is inserted into the population. Then fitness evaluation. It is evaluated using this equation. Then is a semi-constructive crossover method. The probability is taken as 0.8. And then parents are selected based on the incest prevention based selection. Then the crossover method, first two random positions are selected here in the figure C1 and C2, and then the parent is split into two parts: static part and dynamic part. Static part is the part on the either end of the parent, and the middle portion is the dynamic part. Static portion is copied directly to the child, and the dynamic portion is taken, and the genes are inserted one by one using NH-based procedure in the order of appearance in the other parent into the child. Then it's semi-constructive mutation. Probability is taken as 0.05. The worst individual from the population is taken for mutation. So again, two random positions are selected, and the middle portion is removed and shuffled and reinserted one by one into the individual using NH-based procedure. Then is a local search technique method using simulated annealing. So for this, the best individual from the population is selected, and the initial temperature of the simulated annealing is calculated using this equation. Also, the number of iterations at one temperature is 4, and the decrease rate is 0.95 T. So the stopping condition of the simulated annealing is minimum temperature equal to 0.01. Also, the method used to generate neighborhood solution is swapping, in which two genes are randomly selected randomly and interchanged. So then the step is population updation, that is replacement in each iteration. So for one iteration, a maximum of 4 individuals, 2 from crossover, 1 from mutation, and 1 from simulated annealing will be generated. So these one by one will replace the worst individual of the current population. So at last, the stopping condition will be checked. So compute this value n into m by 2 into 90 milliseconds. This value of computation time, it will be calculated. And if the current computational time is less than the this calculated value, then the algorithm will proceed to the next iteration. That is to step 3, step 4. Else, if the stopping condition is reached, the output, that is optimum sequence and minimum make span, will be displayed. So this algorithm was tested using 120 Taylor benchmark instances of STST 100, and the results 120 results were calculated, and these results were compared with that of the genetic algorithm. So the first graph shown here is that of a 20-job 5-machine problem. That is for 10 cases. So for 10 cases, the graph of 20-job 5-machine problem is shown here. So like that, 12 set of problems are given here. First is 20-job 5, 20-job 10, 10 machine, 20-job 20 machine, and so. 12 sets of problems. 12 into 10, total 120 problems were tested. And the orange line is a make span value calculated using a genetic algorithm, while the blue line is the value calculated using MASC, that is a proposed genetic algorithm. So in all these graphs, we can see that the result obtained using MASC is clearly less than that of obtained using genetic algorithm. So to quantify this reduction in the make span, a value called relative percentage improvement was calculated using the equation make span using GA minus make span using MAC by make span using GA into 100. So this value was calculated for all the 120 cases, and it was again plotted per set of the problem per problem size. So for all the 12 cases, it was plotted. So we can clearly see that for the small size problems, that is 20 job and 50 job problems, the RPI value is around 3, 4, 5, around that percentage, that range. But for larger problems, this increases to 8, 9, and 10, close to that value. So it is seen that we can say that the reduction in the make span is large for larger problems compared to GA. So again, this RPI value was calculated the average was calculated per problem size. So these are the values per problem size of average RPI. So you can see that the average RPI increases with increasing problem size. So again, this variation was plotted in a graph. So here we can see that the average RPI increases with problem size. So it can be said that the as the problem size increases, the significance of the MAC can be clearly seen here. That is, it gives better results for larger problems when compared to a genetic algorithm. So these are the conclusions. This study proposes a genetic algorithm using constructive operators to solve STST flowchart scheduling problems. And when tested using 120 instances of STST 100 benchmark problems, MAC gives reduced MAX1, that is better results compared to genetic algorithm. Also, then the graphical analysis was conducted, and then the RPI values were calculated, and the average RPI was maximum in the case of 20 job 100 machine problem, that is 9.26%, and average RPI was seen to be increasing with the problem size. So this study proves the significance of the proposed algorithm under varying problem sizes in solving STST flowchart scheduling problem. Also, the reduction in the MAX1 by MAC is relatively high for larger problems. So we know that in real life industrial problems, large size problems are more common. But exact solution methodologies are not effective in, for solving such problems. Therefore, the applicability and effectiveness of the proposed algorithm to large size problems is a significant achievement and contribution to the area of industrial scheduling. So these are the references. Thank you.
Thank you, Vaishnav, for presentation. Next is question and answer session.
Okay, Vaishnav,
Yes, sir.
it was a good presentation.
Yes, sir,
I
thank
have
you.
some very basic doubts only. You told it depends upon the size. As size goes up, it is more effective. Like
Yes,
your,
sir.
new proposal. What is the size normally? You also told that for a small size problem, more relevant is exact methods. Like,
Yes, sir.
what is the size you are looking at normally for that classification? Where exact methods are more prevailing.
That is for some
above 100.
two machine small two machine three machine two machine problems such problems.
Okay, and above 100 you classify it into large size.
Yes, sir. It depends on the job and number of jobs and number of machines also.
No, you told somewhere 200 size and all, which
Yes, those are large size problems, 200, 500 and all.
Okay. And is there any correlation which you can make with the cost effectiveness with these two methods? Any publications are there? Because is it a good value that around 9% improvement?
Yes, sir. That is a good result. That is a 9% is a comparison value with genetic algorithm. But the MAX1 value is a good
algorithm values are your own values or a reference value from a
no, that is another paper reference value.
They are using the same conditions, boundary conditions. All those things are same.
Yes, sir. It is a STST 100 benchmark. Yes, sir.
So which publication did you that 2020 you have you quoted some publication? Is it that
no,
paper?
that is a algorithm. New algorithm.
Okay, which publication did you refer? This one for genetic algorithm as reference?
That is an old paper. My guides paper actually.
Okay. Okay. So you say that 9.9% is something very good.
Yes, sir.
Anyone has reported higher values or lower values? Highest?
No, sir. Far? That is just a comparison value with the genetic algorithm. Genetic algorithm is a standard method. So this for the testing the algorithm for solving this type of problem, it was compared with the results of genetic algorithm. So the clear result of this is the optimum sequence obtained and the minimum make span obtained.
Okay, so is it the first publication in which it is compared with the genetic algorithm? No, I just wanted to know what were the results obtained by earlier publications.
Sorry, sir, I didn't understand.
So you compared with your genetic algorithm and projected that around 10% improvement is there.
Yes, sir.
I just wanted to know the results from the previous publications on the same context, whether they have compared they have done similar studies.
Of which algorithm? Genetic and which algorithm?
And your new proposed algorithm.
No, sir. This is a new algorithm that was not used to solve STST in Indian papers.
Okay. So it's a totally new one.
Yes, sir.
Okay. Okay. Good question. Thank you,
sir. Thank you, sir.
Vaishnav?
Yes, sir.
Vaishnav, very good presentation only.
Thank you, sir.
I just I would like to ask one question only. Is there any this new proposed algorithm, is it capable of filtering out this local optima?
Yes, sir. Yes, sir. Simulated annealing is used for local search, so it is it is capable.
Capable of. Okay. Then how why you are setting up this mutation probability? It is 0.05. Any significance for that?
No, sir. That is the value given proposed in that that work where the algorithm is proposed. That in that paper.
Okay. Mutation probability 0.05.
Yes, that is given in that paper. So I just took the same value.
Okay. What is the significance of that 0.05?
Significance means at that value the results are better, but if you change the values the results are getting bad. That means we are not getting such good results.
Okay, thank you. Okay, thank you, Vaishnav.
Okay, sir.
വൈഷ്ണവ് കേൾക്കുന്നുണ്ടോ? ഹലോ.
ഉണ്ട് കേൾക്കുന്നുണ്ട്.
Okay. In this work you have considered a population size of 100. Whether that population size you have taken just random or you have taken from the earlier paper?
I took it from that paper. It's a value taken in that paper, sir. I just took the same value.
This genetic algorithm in that paper also they have used the same parameters, or whether they have used different parameters? For example,
no, sir. I don't know the parameters. I just took the results only.
Okay, but these parameters also will affect the solution, right? For example,
yes, sir. But these are different types of algorithms. So should we consider? I don't know, sir, about that. I only took the results.
Okay, that in genetic algorithm also we
yes,
use almost similar procedure. We'll take some population size, and after that,
yes.
all this crossover, mutation, etc. We use in genetic algorithm also.
But no simulated annealing is not taken there.
Yes. So what can you qualitatively say? What would be what is the basic reason for improvement when we use genetic algorithm or this mimetic algorithm over the GA? Why our solution is better?
There are different reasons. One is the use of local search method, that is simulated annealing, and the other method is the crossover itself is different from the typical crossover and mutation techniques. here it is a NEH based crossover and mutation.
Okay, can you elaborate what does mean by NEH based crossover?
So NEH based means NEH is conventionally it is a heuristic method used earlier, used a long time before.
Okay.
So in that method, the suppose the processing time of some number of machines for n job m machine problem is given. Those are sum is calculated and the sequence is arranged one by one based on the calculating the minimum ink span. That is a technique. So that technique is implemented using the crossover method for insertion of genes from the parents to the children.
Okay, fine. Thank you, Ashwin. It was a good presentation.
Okay, sir. Thank you.
Any questions from audience? No questions. Thank you, Vaishnav, for beautiful presentation. Next, I welcome Adilraj PP of Government College of Engineering, Kannur, for next presentation.
Okay, sir. Thank you.
Hello, sir.
Yes.
My topic is review of various algorithms used for solving parallel mission scheduling problem with the job splitting. These are the contents. Parallel mission scheduling problem is a process of scheduling of job processed on a series of machines with a optimized objective. Parallel missions can be classified as identical, non-identical, and uniform parallel missions. When total demand of a product is considered as one job in scheduling, it can be split into different missions so as to finish the total demand as soon as possible. This kind of problem is called parallel mission problem with job splitting. EMS problem with job splitting is NP hard, that is non-polynomial hard problem, and it can be solved by using both exact and heuristic method. Next is parallel mission and job splitting. Parallel mission, there are M mission in parallel. Jobs are requires a single operation and may be processed on any one of the M missions. Job splitting means job denote a production order consisting of several identical items. When total demand of the product is considered as one job in scheduling, it can be split into different machines so as to finish the total demand as soon as possible. These are some of the performance measures mainly considered while solving a parallel mission problem, that is flow time, the amount of time a job spent in the service or manufacturing system makes span the total amount of time required to complete a group of job. Tardiness, the difference between the total completion time and due date, or the amount of time by which a job missed its due date, or percentage of total job processed over some period of time that missed their due date. Earliness is the measure of finishing operation before due date. Here, make span is the most commonly used performance measures in parallel mission scheduling problem. Different algorithms used for EMS problem are both exact and heuristic approach. Various algorithms for solving are genetic algorithm, simulated annealing algorithm, branch and bound algorithm, and memetic algorithm. Sir, here this paper, a genetic algorithm is performed to minimize the make span for a real life problem considering looms in textile industries. Each machine has its own processing time according to the characteristics of the machine as well as job type. There are machine and sequence dependent setup time. Here all the jobs can be divided into sub-job in order to deliver the orders on time. The problem considered here is 2-job 3 machine problem. This is the population size 80 and 100. Probability of crossover is 0.51 probability of mutation 0.2 to 0.5. Here the results showed that the suggested algorithm can find solution for problem with 75 machines and 111 jobs in a reasonable amount of CPU time. Here also, in this paper also, the genetic algorithm is considered for unrelated parallel mission scheduling problem with the sequence dependent setup time. Here, the non-identical parallel mission is scheduled by using the genetic algorithm. The common steps are population initialization, fitness evaluation, selection, crossover evaluation. Then here also the number of machines considered are 2, 3, and 5. There are many other algorithms. Here they considered simulated annealing algorithm for solving unrelated parallel mission. The objective is to simultaneously determine the job mission assignment and the job sequencing on each mission so as to minimize the total weight processing cost. In this study, we consider a hypothesis problem with 80 jobs and 5 unrelated parallel missions. The processing time for each mission is given. The procedure for simulated annealing algorithm is initialization. Choose a initial feasible solution S to be the current solution and compute its objective function value. Then select another feasible solution S dash, which is neighborhood solution of this S, and again compute the objective function value. Test whether to accept this S dash or S. If S dash is most relevant, then replace S with S dash. Next is termination test. Test whether the algorithm should terminate. If terminate, output an appropriately chosen solution. Otherwise, return to the neighborhood generation step. Here, this paper examines the parallel mission scheduling problem with the objective of minimizing total completion time considering job splitting and learning. Here, a branch and bound algorithm, which is an exact solution, is used for solving the problem. Here, in this paper, a job denotes a production order, which is composed of number of discrete identical items. The job is completed only after all items within the job are finished. In addition, a job can be split into several subjobs to be processed on parallel machine, which result in reduced throughput time but improved delivery time. In branch and bound algorithm, each node in the branch and bound tree corresponds to a partial schedule. When a node is branched, one or more nodes are generated by adding one or more job in front of partial sequence associated with the node being branched. The selection of node to branch from follows the depth first rule, where the node with the largest number of jobs in the partial sequence is selected. Tie, in the case of tie, select the node with the minimal lower bound. The results showed that branch and bound algorithm is efficient at optimally solving small sized problem with it. When m is smaller than 3 and smaller than 8, the items per job are smaller than 10. Memetic algorithm also here this paper focused on the problem of solving scheduling a set of independent jobs with setup time and job splitting on a set of identical parallel missions such that total tardiness is minimized. Here a memetic algorithm is used for solving the problem while considering job splitting. The number of jobs taken here are 10, 15, 20, 25, 40, and number of machines taken are 4, 8, 12, 16, 20. This is the flowchart of memetic algorithm, that is start generation of initial population, local search, evaluation, then stopping, check for stopping criteria for, and again selection, crossover, and mutation. These are some of the papers I referred for getting knowledge about different algorithms. These are the references I referred.
Atul,
Yes, sir.
can you show me the results, final conclusion slide or results slide?
This is only review section. That is, I reviewed only different algorithms.
Okay.
used for scheduling.
But you told actually it's a comparison.
Yes,
Comparison in on what basis actually? Your times, various process parameters only.
sir, അത് different capability of different algorithms for solving. That is number of jobs and number of machines.
Okay, so it's a basically review paper only.
Review paper only.
But then, what is your conclusion on a specific case? It would have been better if you had a comparison between different algorithms. Do you have any comments on that? That means various algorithms you are trying to compare, right?
Yes.
Instead of listing out for a specific cases or one or two specific cases, can you tell us which one will be better on how far
Sir,
it will be better?
if you take a simulated annealing algorithm, we will get more accurate result.
For what size? Large size.
A large size problem.
What is the size you are looking at?
Sir, the size is more than 25 jobs machines.
Okay. So, what is the value you are expecting, or how better will be the one simulated annealing over the other methods?
Sir, make span will be reduced than that we using genetic algorithm.
So it would have been better if you had a good comparison. Okay, based on some specific one or two cases, you can highlight one particular method will be better in what you can quantify also based on the literature which you have gone through. You can project the results also actually.
Okay, sir.
Yeah.
Yeah.
Okay.
Atul?
Yes, sir.
Okay. So this you have compared different solution methods, right? So
Yes, sir.
can you? Sorry. It was better to mention the specific problem solved by each of this method. Rather, you have just added.
Sir, I different problems considered.
Okay,
Different
on all this paper they have solved different kind of problems, right?
kind of problem.
Okay. Okay, you can added the you could have included the parameters they have taken for different problems, etc. Okay, fine. Thank you.
Thing.
Sudeep sir, if you have any...
No. Thank you, Adil Raj. Nothing
Thank you,
more
sir.
I have to ask, sir.
Thank you, sir.
Participants,
Okay.
any questions from participants? No. Thank you, Ajit, for presentation. Next, I welcome Alan
Thank
Jessis
you, sir.
Jacob of Government College of Engineering, Kannur, for presentation.
Good morning, sir.
Good morning, Alan. Please.
Good morning, everyone. My paper is about review of fabrication process of aluminum metal matrix composites, and these are the contents of my paper. And the main objective of this study was to conduct study about metal matrix composites, study about various methods used to fabricate these aluminum metal matrix composite. Aluminum was chosen as the base metal for this study, and explore various literatures for methods used for fabrication of these metal matrix composites. And for a brief introduction, metal matrix composites are the materials which have a base metal, which will be either be a metal or an alloy, and it will be reinforced with some addition, reinforced with some materials to increase the basic properties of these base metals or alloys, so that we can get desired properties from the base metal. The base metal will be having some weaknesses which won't be suitable for some applications. In order to make these base metal to be applied on these for these purposes, we reinforce them with some other materials so as to achieve the properties we require. And usually these metal matrix composites are created for increased wear resistance and other mechanical properties, and it will be when compared for performance of these metal matrix will exhibit a higher performance when compared to these uh, base materials before reinforcement. And the metal or alloys can be used as this matrix of materials, and reinforcements are usually soft lubricants or solid reinforcements. And I have chose aluminum for this study, and aluminum uh, has a wide range of applications, and because it is the most abundant element, and it is favorable because of its many mechanical properties like electrical and thermal conductivity, non-magnetic in nature, etc. Aluminum alloys are the alloys in which aluminum is predominant metal, and it will be having some of the such as copper, magnesium, etc. And main applications of uh, aluminiums are in the sectors like electrical conductors, automobiles, aviation sector, and satellite, camera, etc. And various forms of reinforcements are used in aluminum alloy. The commonly used reinforcements include silicon carbide, aluminum, etc. And this can be either in the form of small particulates or fibers or a large viscous, etc. And the aluminum having property of lightweightness is most favorable property of aluminum, which is by which it is commonly used for many applications. But the aluminum has major flow of high wear rate. So in order to enhance this wear rate, reinforcements are mainly used, and it is fabricated according to the applications. And metal matrix composites of aluminum are very widely used in automotive industries and aviation industry. These are the literature which I have used for this review, and I have summarized the literature review in the following slides. So we are reviewing about the fabrication processes for these aluminum metal matrix composites, and the fabrication process is mainly divided into two: liquid phase processing techniques and solid phase processing. There are many more modified versions of these fabrication techniques, but basically the base principle are basic methodologies are listed below. In liquid phase processing techniques include stir casting, combo casting, skews casting, spray casting, or deposition. And solid phase processing include friction stir processing and powder metallurgy. Stir casting is the process in which the reinforced phases are executed into the metal matrix by mechanical stirring. It includes melting the base metal and stirring it mechanically with stirrers in large stirrers. And stir casting, major advantage of stir casting is that 30% volume reinforcement can added to the base material. The molten alloy, after mechanical stirring with the reinforcement, is casted using a furnace, and casted material is extruded after the process. And the major factors affecting this process are stirring speed, temperature, blade angle, and preheating. Major concern, but major disadvantage can be noted as the segregation of reinforcement particles. That is, the reinforcement particles sometimes in the surface may not be attached to the metal matrix compound, so it like holds up when these causing porosity, etc. The next method is combo casting. It is the process of adding reinforcement particles into solidifying matrix. That is, a metal or alloy is heated and it is melted into a liquid form. And when this heating is stopped and the base metal is solidifying, the reinforcement particles are added to the matrix. And it is slightly different from the stir casting process because there is no stirring. The reinforcement are added to the solidifying matrix, and it is economical method compared to stir casting. And the casting composite and casting composite, the reinforcement are usually fibers or viscose, and the major difficulty is adding very fine particle size. Fine particles will cause clustering or segregation from the base matrix. This process is very sensitive to conditions like ambient temperature and other physical environmental factors, and it is more expensive process as it includes this as it requires more controlled environment for this process. The next process is fuse casting, in which molten material is compressed within a mold with adequate superheated reinforcement together into a desired shape. The major advantages of these processes, it has due to this, it is created in the mold, and there is a capability of mass production, and it has more improvements in the overall production factors, which include these quality and the includes quality and proper control of these all techniques. And it has also a major advantage that we can reinforce selected regions or selected areas of this base metal. The major defects which can occur during the fuse casting are there is a chance of occurring a fracture or adding or the breakage in the fiber we are adding as a reinforcement, and it may have porosity. There is high chance of creating porosity in the surface of the metal composite, and flow segregation may also occur due to this high pressure acting on top of these metal matrix. And the next method is spray casting or deposition. This atomized molten particles of reinforcement are sprayed into the metal matrix with a high velocity to the heated base metal, and reinforcement particles are compacted with the melt spray, allowing engulfment in the molten or partially molten metal droplet from a composite. It includes the major application of spray casting are used in aerospace industry, transport equipment, and the disadvantages include excessive overspray and poor shape control are disadvantage. Due to these high velocity spraying, poor shape control, there is a chance for poor shape control. And the next one is powder metallurgy. These fine powdered materials are combined together and they are pressed to get the desired shape. These reinforcements are compacted powder, and they are heated in a controlled atmosphere to bond the material with the base material powder. And complex shapes, the structures are easily fabricated with high accuracy. The compacting and sintering at low temperature compared to other processes result in homogeneous dispersion of reinforcement, which is a good quality of this process, and it has a low processing cost and high versatility, and it helps in creating more number of products, like just like mass production of the required shapes and structures. Next one is friction stir process. It is a solid state processing based on friction stir building. It is effective and efficient technique which can be used to refine microstructure and to fabricate MLCs. Friction stir processing is mainly used to refine the surface properties of mechanical matrix composites, and various plastic deformation techniques is used to improve the surface properties. And in friction stir processing, the important characteristics are tool rotation speed and traverse speed. Variation of these tool rotation speed and traverse speed has a great effect on these properties of the surface. Increased tool rotation speed or traverse speed gives finer surface finish of these fabricated metal, and the metal matrix composite created by friction stir process exhibited high wear. So, in conclusion, metal matrix are more advanced materials. Composites are more advanced materials which provide definite properties which required according to the applications. Aluminum metal matrix composite has been the best suited material satisfying this need. Fabrication of methods used for aluminum metal composite can be broadly of two types: solid state processing and liquid state processing. Stir casting is the most common liquid state process used for fabrication of aluminum metal composite. Other liquid phase processes include combo casting, fuse casting, and spray casting. Solid phase techniques include powder metallurgy and friction stir processing. Powder metallurgy is the common used solid phase technique. Friction stir processing is used to improve surface characteristics of metal composite. Fabrication of composite with friction stir process helps to achieve excellent surface finish and construct which result in superior wear resistance and other mechanical triviological properties. Thus, heating metal composites helps user to aluminum by reducing its unwanted properties which affect the efficiency and life of metal. Metal materials can be added to the metal according to the required application. These are the references I took for this review. Thank you.
Alan, your conclusion slides, please. Next. What is that last point? Different materials can be added to the metal matrix according to the required application.
Yeah. So the base materials may have some properties which are not suited for the applications, and there may be some other reinforcement materials which have the properties we want but does not have the properties of these base materials. So this reinforcement can be added to the base materials so that we get both properties in a single composite.
Can you give some examples on that specific case?
Yes, I have done a project on this aluminum metal matrix composite. So I have I had aluminum as the base material and graphite as the reinforcement. The main applications, the main application was in the sliding sliding structures of internal combustion engine. So aluminum is preferred because it has lightweight and lightweight structure. Overall lightweight weight was so low for aluminum, but aluminum had great wear rate. So graphite is added to this base aluminum so that it will reduce the wear rates, and also does not increase the weight of this aluminum. So usually the engine blocks are made by iron, I mean cast iron structure, which is heavy in overall weight, and so aluminum was an aluminum is acting as a substitute for this cast iron, so it has lightweight, but it had more wear rate compared to cast iron. So graphite is added as a reinforcement for this aluminum, and it acts as a dry lubricant.
Okay. What is the, how many numbers of journals you referred for this review? This is review also, no, basically?
Yes, sir. Yes, sir.
Ah.
Almost 50 papers.
Okay. What is this volume fraction of reinforcement? Somewhere you told, I couldn't understand.
Yes, sir.
Volume fraction of reinforcement, something you told.
That is how much of reinforcement can be added to this base structure.
How will you quantify that?
It was from the literature I found out that.
Okay, Alan, leave it. Still casting there only.
Yes.
Okay, good.
Yes. Thanks.
Alan?
Yes, sir.
Okay, you have made a nice review. You have covered almost all the aspects of the aluminum metal matrix composites. I have only one or two doubts to ask. Normally, we are doing alloying for enhanced mechanical properties, correct?
Yes, sir.
Okay, we can add copper to aluminum or magnesium to aluminum. Sometimes even aluminum magnesium silicon alloys. All these processes we are doing for enhance one or two
Yes,
mechanical properties. So, what is I want to ask is what is the fundamental difference between solid solution alloying and the metal matrix composites? Alloying is a method for improving the mechanical properties. So,
yes, sir.
what is the fundamental difference between alloying and this metal matrix composites?
So, alloying, it enhances the properties of the base metal we are choose for. I mean, it only enhances the mechanical properties, but by the help of these composites, we can actually change the overall property. That means we may, if we may take aluminum and graphite for example, aluminum has more wear rate, but graphite act as a dry lubricant. But we can't alloy graphite into aluminum, so we make this composite of aluminum and graphite. So the base, this composite will have all the properties of aluminum, that is lightweightness and etc. And the graphite acts as a dry lubricant around this aluminum, creating a composite which has less wear rate and all the lightweightness of aluminum.
That is what I am asking. What is the fundamental difference between alloying and the creation of metal matrix composites? Is there any fundamental difference between these two processes, alloying and metal matrix composite?
Yeah, the fundamentally thinking, it is almost the same, increasing the properties according to our requirements or application.
So, if that is the case, means suppose I am adding copper to aluminum.
Yes.
Okay, aluminum 2x series. Can it be say? Can we treat that one as a metal matrix composite?
That I should study more about it, sir. I am not sure.
Okay, leave it. Okay. Then you have mentioned one more simple question. The one clarification of doubt only. That is spray casting. You have mentioned one process for the metal matrix. That is for generating metal matrix composite. Spray casting. Is it a surface treatment, or that composite will be available in the core of the metal?
Yeah, it will be overall homogeneous material.
So you are spraying these particles to the substrate only, na? Just
Yes,
take
sir.
that example
Yes,
where
sir.
you have mentioned spray casting.
Yes, sir. it is deposited onto a substrate, both the base metal and reinforcement.
On the surface or the inner core?
On
Whether
the surface of the substrate, but this substrate act as a landing point for both of these metal and these reinforcement.
so whether we will get a homogeneous reinforcement throughout the material, base material, or it is a
Yes,
surface treatment, or it is a surface treatment only. That is my
no, it is not a surface treatment.
not a surface treatment. Okay, okay. That's all. Very nice. You have covered almost all the aspects of metal matrix composites. Okay, thank you, Alan.
Thank you, sir. Thank you.
Okay.
Okay, Alan, are you able to
Yes,
hear?
sir. Yes, sir.
Okay. You talked about the graphite reinforced aluminum
Yes,
metal
sir.
matrix composite. Okay. What are the some of? Can you name other reinforcement materials we are using in an aluminum
Yeah,
metal matrix?
usually silicon carbides are used with aluminum, and fly ash, various forms of graphite substrate, etc. are used.
Okay. I think you have done experiment on this graphite reinforced.
Yes, sir. Yes, sir.
Okay. So whether you have manufactured that or
Yes, I fabricated the metal.
okay. What method you have used for that?
I used combo casting. It is not actually more scientifically, not a scientifically accurate method, but almost the base principles of combo casting was used.
Okay. Thank you.
Thank you.
Any question from audience? Okay. Thank you, Alan, for presentation.
Thank you, sir.
We will have
Hello, Ashwin sir. Oh,
there are
okay.
some problem. So we will resume the session at 10:40. Now we will have 5 minutes break. Now we can resume the session. I invite Preet Mahipal of College of Engineering, Talacheri for presentation.
Thank you, sir. My teammate Rahul will be taking over the presentation. It wouldn't be a problem, right?
No.
Let me start the presentation.
So, good morning, everyone. First of all, I thank everyone for providing us this opportunity to present our paper on this conference. So, I am here to present on the topic modeling of coefficient of drag for self-adjusting windshield of adventure tourer motorcycle using CFD. Even though the heading seems to be a little bit big, this project is based on a simple idea that we imposed on the working of windshield. So windshield is a part of bike or an aftermarket accessories which is used to provide protection to the riders, to provide comfort from and to provide avoid the wind blast that is hitting to the rider, and also it aids to the what overall aerodynamic performance and efficiency of the bike. Even though most of the motorcycle users have windshield on their bike, okay, but many of them are unaware or they does not feel the actual effect of the windshield that is working, okay. The main reason behind this is that we mostly use the motorcycle for the commuting purpose, like going to the market or nearby areas. We are mostly riding the motorcycle through the cities below the speed of 80 kilometers per hour. But apart from that, there are certain people who rides the motorcycle through the highways or tour in them above the speed of 100 kilometers per hour. They are the people who know the exact effect of windshield and how the windshield affect the aerodynamic performance and efficiency of the bike. So I am here to present on the topic how the windshield is going to affect the aerodynamic performance of the bike. So our aim of the project is to model the coefficient of drag by finding the optimum parameters up to the top speed, so that we can provide a sufficient data by which the automatic adjusting mechanism can be designed in the future. As I said, the advantage of the motorcycle windshield, there is also some limitation. Okay, the windshield is completely inefficient after a particular limit of speed. Even though many manufacturers have provided the adjusting mechanism in the windshield so that we can adjust the angle and height of the windshield. Even though as we are humans, we are not able to obtain the correct optimum position where the windshield needed to be kept for producing minimum coefficient of drag. So we are aiming our project to overcome this problem. So basically, we need the data for doing the project. So we get the data like how the windshield affect the aerodynamic performance of the motorcycle, how different design of the windshield affect the aerodynamic performance, how the inclination of the windshield is going to affect on the coefficient of drag, and other kind of things. How we can do the experiment in the ANSYS Fluent and CFD. These stuff were taken from the literature review that we have done. So these are the literature reviews. So as I said, our objective is to model the coefficient of drag using different parameters like inclination, height of the windshield, and speed of the bike. And we are aiming to provide an advisory system for self-adjusting windshield for better aerodynamic. So as a basic final year student, we were thinking that this is going to be easy because we only need to do the geometrical part, and then we need to do that in CFD ANSYS or using analysis software so that we can get the result. But it was not that much easy for us. There are certain steps that we need to strictly follow for achieving the project. So these were the methodology that we use, like selection of parameters for CFD analysis. We do it with the help of literature review that we have done. The next step was the design of experiment. And the third one was geometric modeling, which is basically done in PTC Cryo 6.0. Then CFD analysis was done in ANSYS software. Then modeling of coefficient of drag. Then prediction of parameters for minimum coefficient of drag. That, for example, if the bike is moving in a 140 km/h, there is a particular position the windshield need to be angled and the height is needed to be set for producing minimum coefficient of drag. So as I said, we need to finally we need to select a bike before we start the project. For the criteria for the selection of bike that we include was it should consider the effect of windshield. Okay, and also it should have a cruising speed of 100 to 150 km/h. As I said, the windshield come into action above a speed of 80 km. Okay, and it has a limit up to which useful of the working of the windshield is limited. Okay, so we should have a cruising speed of 100 to 150 km/h, so that the bike can cruise up to a limit of 200 till 200 km/h as its acceleration is possible. So we have chosen the power above 35 bhp. Okay, so that we can easily accelerate the bike through the highway. We also have chosen an adventure tourer motorcycle because mostly the tourers or the people who are touring in the highways choose the adventure tourer motorcycle for riding or touring purpose. And finally, we have get into a result like we have chosen the bike Triumph Tiger 900 Rally Pro for our project. So from the literature review, we came to understand that there are certain influencing factors which affect the coefficient of drag. So the most affecting factors was speed of the bike, the inclination of the windshield, the height of the windshield. Okay, so in the right side we can see the picture about adjusting the height of the windshield and inclination, and the range was also selected with the help of literature review that we have done, and the range of speed was 80 to 200 km/h. The inclination was set to 30° to 75°, and the height is set to 0 to 80 mm. So after doing the literature review and choosing the factors, the next step was to design the experiment. Okay, design of experiment, which was a crucial part in every project. So basically, if we saying an example, mm, if we got a problem, okay, first we will find a solution, identify the problem, then find a solution, then test that problem. Okay, but DO is entirely different. It focus mainly on providing the test knowledge. Okay, it focus on the test knowledge that we acquire rather than finding the solution. So with the help of DOE, we were able to know what are the influencing factors in our project, and how we can take the ranges, okay, in between these factors varies. And there are different kinds of DOE method that we need to choose. Okay, but the next question was what method from this DOE. There are methods like Factorial Method, Response Surface Method, Taguchi Method, and the next task for us to choose the methods, the apt method to do the project. So we conducted through studies that we came to know that Factorial Method is a process in which we run in which each trends are run with each possible treatment. Okay, so basically we have three factors and three levels. So if we take the number of experiments, it is like 3 raised to 3, 27 experiments have to be done. So with the current resource that we have, it is a little bit tough task for us. And also the Factorial Method only shows linear trends. Okay, it doesn't have higher order trends, it only shows linear trends. So we were able to sort out the Factorial Method. And also there is another method known as Fractional Factorial Method, which shows similar characteristics like full Factorial Method. So we were able to sort out the Factorial Method. The next method in front of us was the Taguchi Method. So we came to know that basically the Taguchi method is a process, is a method that we usually take in the experiment that contain uncontrollable factors or noise. So by checking the practicality, there is no uncontrollable factors in our project. So we were able to sort out that method also, and we have chosen the response surface method for our project, which have the advantages like it assumes all the factors are significant, and it shows a quadratic or higher order trends, and optimization is possible in that. And in the response surface method, there are two sub levels like central composite method and Bosmangan method. So from this, which one? It was a next task. So through our studies, we came to know that central composite method have better advantage than the Bose-Bengen method, but also it is not that much easy for us to have a result with the fourth order response surface. Okay, the CCD will give only a fourth order response surface, which is much more complex and difficult for us to understand. And also it also includes two extreme axial points. Okay, mainly we have taken three levels like minimum, medium, and maximum, and above that we also need to consider two extreme axial points for doing the CCD method. And by checking the practicality, if you take the example of inclination, and if you take the extreme minimum point, it is like 0 degree. Okay, basically at that condition there is no use of ISO. So we does not need any extreme axial point for doing our project. So we were able to sort out the CCD method, and we choose the Bose-Bengen method as the apt method, which have an advantage of optimization, response surface creation, and with the current resource that we have, it was the best method for doing the project. And in the right side, you can see the design table that we created with the help of Minitab software. It contains 15 experiments. We have done the 2D modeling in PTC Cryo 6.0. As we can see, there is a small black part which is actually represent the bike and the mannequin. We have taken only the half portion we have about the tire section because it doesn't have that much effect on coefficient of drag. So we have only taken the upper part. And the rectangular part, okay, blue rectangular part that we can see is known as the fluid domain. Okay, so we have taken the length as fluid domain length as 20,000 mm and height as 5,000 mm. We can even reduce the length of this reduce the dimension of this fluid domain. Okay, but it may cause some errors in the result that we have got. So because of that, we have increased the fluid domain dimension, and this is the fluid domain created. Next thing was the experiment setup that we have done in the CFT. Like we do the CFT in ANSYS software. Here we can see the meshed geometry. Okay, the meshing number of elements was 1,24,365. We can even reduce the number of elements, but it goes as the time, and also the resource should be much more higher for doing an experiment with higher number of meshing elements. So to get an accurate result, we have created an sphere of influence. Okay, as we can see in the bottom figure, there is a sphere that we have created around the bike and fluid domain. And the main use of this is that it makes the area under inside that sphere much more finer. Okay, so that we can get an accurate result at that area. So after creating the model, we import that into the ANSYS Fluent software in the step format, and we select the solver model as SST K omega model, which represent like shear stress transport, K represent on kinetic energy, and omega represent on turbulence dissipation rate. The zone was set to fluid like air, and we created the boundary condition like velocity inlet and pressure outlet. And velocity inlet, as we can see, it was the range that we select, like 80 to 200 km/h, and the drag was calculated. We run the iteration for 3000 times, and we got the result converged before the 3000 iteration, but we also run for a 500 iteration more to get more accurate result. The experiment of 2D analysis is given here. In the left side, we can see the table of factors and their range that we have selected with the help of literature review and DOE. And in the right side, we can see the table, okay, that we created using the Minitab software. There is 15 experiment, and the inclination, height, and speed is given there. So we created 15 model, and we have done 15 experiment in ANSYS software. Here we have provided an example. Okay, we have put the inclination as 75 degree, height as 0, and speed as 140 km/h. And the response that we got is 0.30965069 coefficient of drag. And it took somewhat about 60 minutes to complete the result. Okay, and from this we concluded that the method that we choose and the way that we created the experiment was correct. We had also provided the plot, okay, contour plot of pressure contour, velocity contour, and streamlines here for understanding the result. Here is the test result that we got from the ANSYS software for the 15 experiment, and the drag is shown here. It ranges from 0.6 to like 0.35, 0.4, like that. and the maximum drag that we have got is 0.6. After doing the test, we conducted an Anova analysis. We can see here the F value and P value is generated. And if you take an example for the inclination, the degree of freedom is 1, and we can see the F value as 1,82,091, and the F value for the height is little more less, and for the speed is lesser than that. From this, we can conclude that the inclination is the most influencing factor for coefficient of drag. We can also see the p-value for those values like inclination, height, and speed. It is 0, 0, and 0.001. And we have chosen the alpha value as 0.05, and it is less than that alpha value, which obviously shows that we can reject the null hypothesis. The R square and adjacent R square values given the bottom. Okay, it's about 99.99% and 100%, which shows that the experiment that we have done is almost correct. We can also compare the main effect plot. As I said earlier in the previous slide, the inclination is the most influencing factor on coefficient of drag. We can see that from the graph also. The inclination is much more steeper, and the height have lesser effect than the inclination, and speed lesser than the height. So we have created a regression equation using Minitab software. Also, we have avoided the insignificant term from this equation. Like if we check for the inclination coefficient is like 0.01, and it become lesser if we go towards the end, and the interaction for the interaction, the coefficient is much more lesser. So we have avoided the unwanted or insignificant terms from the equation, and the final equation is given here. After completing the experiment, we have created the optimization. As I said, our aim is to find the optimized position of the windshield, which provide minimum coefficient of drag. So we have taken the interval of 10 km per hour. Okay, as an example, we have taken 80, 90, 100 like that with an interval of 10 km per hour. And for that, the optimized value of height and inclination is provided here. Like height is for 80 km per hour, the height is 33.13 and inclination is 75 degree. Like that, for 100, if the bike is moving at 100 km per hour speed, the height, okay, optimum position for the height is 34 and inclination is 75. Here we can see that the inclination is constant as 75. Okay, so we don't need to change the inclination, it is fixed at 75, but the height varies so that we can get a minimum drag. So the drag here we got is about 0.3, something like that. If you check the result that we got from the analysis, the maximum drag was like 0.6. We were able to reduce that to 0.3 by providing the optimum position of windshield here. So this is the optimization plot that we created, and the first graph shows the drag coefficient versus speed, and the second graph shows the height versus speed graph. And with the help of this optimization plot, we have finally created the final result. Okay, with the help of trend line that we created from the optimization plot. And here, as I said, there is no need of any equation for the inclination because we got the optimized inclination as 75 degree, and only the height change. We have created an equation for the height, like the y represent the height and x represent the speed in that equation. For example, if you put x as 140 km per hour, the corresponding y value is the optimum position that we need, the windshield need to be kept for producing minimum coefficient of drag. So the benefits of the project is we have founded minimum value of coefficient of drag and the relation for finding the optimum height. Also, it reduced the risk of accident due to manual adjustment. Okay, in the while during the ride. Okay, as the manufacturers, some of the manufacturers of the bike had provided manual adjustment visors, and it's a boring task to adjust the visor accordingly during our ride. Okay, we are not going to ride at a constant speed. We may raise the acceleration or dip the acceleration according to our mood, and it's a boring process to adjust the windshield accordingly in between the rides. So we have created minimum wind blast on the rider through our experiment. It can be incorporated in electrical vehicle easily and is more reliable. our future plan is to validation of the proposed model with experimental test. Okay, basically we are going to do the test in internal so that we can compare it with the result. Also, we are planning to provide an advisory system for self-adjusting windshield with the help of certain set of sensors and mechanisms. So the conclusion is provided here. CFD analysis study is done using the analysis. A mathematical model is developed to predict the coefficient of drag at different speed, height, and inclination. We have developed a model to predict height and inclination at different speed for minimum drag. The inclination, we have seen that the inclination is the primary influencing factor which affect the coefficient of drag. Also, we have seen that in the optimization table that we created, the inclination is set as 75 degree and it is the optimized value in which the windshield need to be kept. That the height has least effect on the coefficient of drag, and the proposed model can be used as an advisory system for self-adjusting windshield. These are the reference that we have taken. Thank you.
Okay, Preet, it was a good presentation.
Thank you, sir.
Can you please take the literature review slide? So what was the findings from these papers?
So the main finding was we came to know how the windshield actually affect the aerodynamics of the motorcycle, and the other main finding was we came to know the range of angles that needed to be taken. As we can see the table here, they have taken the angle between 30 to 70 degree. Okay, so the range of angle was got from this paper, and also
But you took 75, no?
Yeah, till 75, sir.
Okay. Okay, then why did you want to do that spherical domain, defining a spherical domain and all?
Yeah. So basically, as I said, if we increase the number of elements, okay, the result is going to be more accurate. But
Yes.
there is also a limitation that if we increase the number of elements for the whole area, it become very large and it is much difficult for us to analyze the result. Okay, with the current resource that we have. But we have created a spherical surface. Okay, as we can see in the first figure, here the area is much more finer than the outside place. So if we create a much finer area around this bike and the fluid domain here, we can get an accurate result. Like the coefficient of drag that we get is much more accurate and error free.
The size of the first domain, which is that the first picture, okay, that is based on the size of the bike.
Yeah, sir.
Size of it's exactly same as the size of the bike.
No, sir.
What? How did you fix that domain size?
Sir, actually, we have done a test, sir. A test run that there is a.
Can you enlarge that picture, that first picture? Black, this one, first picture.
Okay, sir. So.
Okay, so the bike is there only.
Okay, sir.
Then the entire domain, how will you fix the size?
Yeah, sir. There is a process known as domain dependency that we do in ANSYS software, sir. Like we can choose any dimension for the fluid domain, but there is a particular dimension at which the result became constant. After that dimension, we will get only a constant result for the experiment that we do. So we have done the test and we have reached to a conclusion that this dimension that we have taken is the apt dimension for conducting the test.
That will be automatically given by the ANSYS, or what will be the input to fix that domain?
Sir, we need to check that, sir. We need to give different dimension. Like we will first reduce the dimension.
You mean something like grid independent study?
Yes, sir. Yes.
Okay. Then you defined a spherical domain, which will give you more accurate value.
Yes, sir. To make the region inside that spherical domain much more finer, sir, so that we can get an accurate result.
Then why do you want to define a spherical object and a domain and all? In the same domain itself, size you can reduce, and mesh size you can make it fine, no?
Yeah, sir, but it goes with the current resource that we have, it will increase the number of elements, sir. If you are making final the entire domain, the number of elements goes increase, and it took more time for conducting the experiment. And with the current resource that we have, it is little more difficult, sir. And because of that, we have chosen that spherical domain, so that inside that domain, the number of elements will increase, and it become much more finer.
And you told somewhere above some particular speed, the windshield is going to be fully inefficient.
Yes, sir.
Can you give me more explanation on that?
Yes, sir.
Anything you found from your result?
So basically, it's a practical condition that if we in every bike, okay, every bike we can see the windshield, sir. But the manufacturer is saying that the windshield will only provide protection up to a particular limit. If we are taking an example, like some windshield will be effective only till 100 km/h. After that speed, the wind blast will hit the rider. So some of the manufacturer are providing the setup for adjusting the windshield, sir. But as a human, we are not able to understand the correct optimum position to the windshield to be kept for producing minimum coefficient of drag. So that was the reason, sir.
But from your mathematical model, you will be able to predict it. Can you do that? Did you come to some such conclusion?
No, sir.
You have only
Actually,
done for a given inclination or something. You will
Yeah.
have to process with different parameters. Then
Yes,
only you
sir.
will be able to get it.
Yeah, get that. Actually, we can actually this windshield can it can be adjusted as height and inclination, so we can increase the height, sir. So we, as you said, we need to check on that for finding the correct speed limit that the windshield become ineffective.
Okay, good.
Thank you, sir.
Okay, Preet, are you able to hear?
Yes, sir.
Okay. Regarding this domain size also, whether you have done any numerical experiments for choosing that size?
Yes, sir. It's actually it is the process is called as domain dependency, sir. That we actually do it in ANSYS software.
No,
We
what?
need to
Okay, I understand. What kind of mesh you have used for that?
quad machines, sir. Quad.
Okay, that's why you have used that spherical domain. If you
Yes,
are
sir.
using it, okay. So, okay, what made you design that entire bike that manner? You could have managed with that front portion only, right?
So yeah, basically we can manage that, sir. But doing the experiment in analysis software, okay, the side view is created because as we can see in this figure, the air is going to be get inside through the left side, sir. So while importing this geometry into the ANSYS software, we need to actually draw the side view. Okay, we are making the section as half, and we are drawing the side view, sir. And from the left side, the air is going to get inside, and it will hit the visor and that part front portion, and it is going to pass away in the side, sir. And because of that, we have created the side section.
Okay. And this windshield, this entire structure is actually a three-dimensional structure. So
Yes, sir.
choosing it as a two-dimensional structure is also is okay. Given your current resources available to you, okay, it
Yeah.
is justifiable.
So,
But with the three-dimensional analysis, it will be much
yes,
more clear, I think.
sir, actually, we have done the 3D also, sir. But we are focusing on doing the validation process in the wind tunnel so that we can compare the results, sir. We doesn't include that in this presentation.
Okay.
Actually, 3D have much more accurate results, sir. We got the entirely different result from that.
Okay, you are done for a similar size domain sir.
Yeah, yes, sir. For the 3D also, the trend is almost similar, sir. For the 2D and 3D, the trend is almost similar. There is only some change in the values, as we can see. When the geometry become 3D, it become little more effective or accurate. So the value is little different, but the trend is almost similar for the 2D and 3D. So we are focusing on doing the validation with the help of internal, so that we can compare. That's why we didn't add that to the presentation, sir.
Okay. In your results also, you are getting the your analysis shows that your angle of inclination is more important when we compare when we consider the
Yes, sir.
drag coefficient. But in your result, your angle of inclination is fixed. How can you justify
Yeah.
that?
Yes, sir. So actually, as I said, okay, the 2D have some kind of limitation of its own. The inclination need to be kept at 75 degree itself, sir, because it shows that the inclination when fixed at 75 degree will give the minimum coefficient of drag, and if we do it in 3D, we can also see the change in inclination.
Okay, in 3D, whether you have used a similar type of a plane type of
No, sir.
windshield, or whether
No,
you
sir.
have...
No. For the 3D, the entire domain is different, sir. It is like three-dimensional. Here we have only used the 2D dimensional, but in 3D the fluid domain and entire thing is different. Instead of a rectangle, we will get a cuboid fluid domain.
Okay, thank you.
Thank you, sir.
പ്രീത്, ഈ നിങ്ങളെ പേപ്പറിൽ ഫാക്കൽറ്റിയുടെ നെയിം കൊടുത്തിട്ടില്ലല്ലോ?
Yes, sir.
Author, only students are authors?
No, sir. We are guided by Professor Nidin Narayanan, sir.
I think it is missing in the...
Sir, Pradeep sir, that paper was before the review.
Yes.
Before the review was done.
Okay.
The paper that was shared to you was before the review, and after review, that was entered, and the paper was sent.
Maybe you can look at the clarity of the pictures also, result plots.
Okay,
maybe you have corrected that one also.
Yeah, right? The comments were sent to them.
Last picture, figure number 7, figure number 6 and all.
Okay, sir.
Not very clear.
Okay, sir. We will check on that.
Okay, thank you.
Thank you, sir.
Preet?
Yes, sir.
Okay. Preet, the presentation was nice only. I would like to ask one or two doubts. So you got a regression model, correct?
Yes, sir.
Okay. So yes, where is that regression model? Yes. Okay. So then how you arrived in a conclusion that a 75 degree angle that would provide the minimum coefficient of the drag? Have you solved this regression model?
No, sir.
For getting the optimum angle?
Yes, sir. We have solved this regression model with the help of Minitab software, sir. And here is the result that we got after optimization, sir. We can do that in the software itself, Minitab. If we enter the regression.
Have you solved whether you treated this one as a minimization problem or maximization problem?
Minimization, sir.
You want to minimize the
drag. Yes.
Okay. Then what is the value of angle of inclination of the visor you got from the solution that you after solving the regression model?
So actually the angle is 75 degrees, sir. For all the...
How you are getting exactly 75? What is the range of value of angle of inclination you have selected for this experiment?
The range is 30 to 75 degrees, sir.
30 to 75.
Yeah.
Means 30 to 75. Means the minimum angle is 30. And maximum angle is 75. So after solving the regression model, you are getting the optimum angle as 75. That is at the extreme point.
Yes, sir.
Is it possible to treat that one as the optimum value? Why I have doubt is you are getting this optimum value at the extreme point. So there is some possibility it can go beyond that 75.
Yes, sir. Yeah.
So is it correct? You are getting the optimum value. You have selected the range as 35 to
30 to 75.
30 to 75, and the optimum value of angle for at which the visor is to be placed, you are getting 75 degree.
Yes, sir.
So that is the extreme value of the angle, the extreme range only, the extreme position of the angle only you are getting. You are saying that it is the optimum angle.
Yes, sir.
So I think there are some chances for this angle which will go beyond the 75. That will give better or lower coefficient of drag than this one. How you are going to comment this one?
So actually, we have done a literature review, sir, and we have got that value, the range of angle as 30 to 70 degrees, sir. But we have taken an extra 5 degree for computing the accuracy, as you said, sir. Basically, from the literature review, we have got it as 30 to 70 degree maximum extreme level, but we have taken extra 5 degree as. But as I said, it may be correct, sir. If the angle also
So
increases.
suppose you are getting for 55, for example, 55.5. Okay, it is well within the upper limit and lower limit. Okay, it is okay. But exactly at the upper limit, you are getting the optimum angle. So, is it fair or not? I don't know. Okay, you have to look into that matter.
So we will check on that, sir. There is a
Okay,
possibility,
and
sir. If the angle increases, sometimes there is a possibility to
yes,
reduce the drag.
possibility. We can't we cannot say whether
Yes,
that
sir.
would be the maximum, like that would be the optimum angle, or
Yes,
there
sir.
are some chances it can be 80 or it can be even 90. We don't
Yes,
know.
sir. Yes.
Suppose we are getting somewhere around in between the upper range or lower range, then definitely we can say that is the optimum angle which will give minimum drag. Okay.
Okay, sir.
Okay, leave that and all. And one more thing I would like to ask, that is. This one normally this coefficient of drag and the coefficient of lift,
Yes,
so
sir.
it is interrelated. Okay.
Okay, sir.
Okay, suppose we are reducing the coefficient of drag. Our aim is we are somehow we want to reduce the coefficient of drag as much as possible, correct?
Yes, sir.
So you are getting 75 degree angle is the optimum angle for the visor, at which you will get minimum coefficient of drag.
Yes,
Is
sir.
it possible to say at this angle it will provide minimum lift
So no, sir.
or
Only it is
maximum lift? Which
no,
is
sir.
preferred, lift we have to minimize or maximize?
So actually, lift should be minimized, sir.
It should be minimized.
Yes.
Okay. So suppose, so what will happen at this particular optimum angle of that visor, or what will happen to lift? Whether it will get increased or whether it will get reduced?
Mainly it will be reduced, sir, because as we at an extreme level of 75 degree,
Uh,
the air is going to be hit on the visor, sir.
how
So
can you say, because in your experimentation you have not included the effect of your parameters on lift?
yes, sir.
So suppose at this value of 75 degree angle lift is going to maximum, then normally what will happen? What will
So
happen to the stability of the vehicle?
yes, vehicle will be reduced.
It will fly away from the road, and
Yes,
or it can provide minimum or maximum what to say friction between tire and road.
yes, sir.
So there would be some convergence. Means the parameters you optimized at that parameter at that value of parameter it has to give a minimum coefficient of drag and a minimum lift
Yes, sir.
or maximum negative lift, correct?
Yes, sir.
So that part is actually missing.
Yeah, sorry, sorry.
No problem. I just mentioned.
Okay, sir. Yeah. Okay,
I just mentioned. We can't predict whether it will give minimum lift or not, or maximum negative lift or not. It is not covered under this investigation. That I just mentioned. That's all.
okay, sir.
Okay.
Okay, sir.
In your future study, you can incorporate all those things. That's
Yes,
all.
sir. We will check on that, sir.
Okay. Nothing more to ask. Anyway, nice presentation. Thank
Thank
you,
you, sir.
Preet Mahipal. Thank you.
Thank you, sir.
Any questions from audience? Okay. No questions. Thank you, Preet, for presentation.
Thank you, sir.
Next, I welcome Mr. Sarang P. from Government College of Engineering, Kannur, for presentation.
Okay, sir. Okay. Good morning, sir. Then my topic is hybridization of whale optimization algorithm. A review. These are the conducts. Then moving into the project. Basically, there are mainly three methods to solve a problem: exact method, heuristic method, and meta-heuristic. In exact method, there is a exact equation for solving. Example, force, equation for force, distance, etc. Then heuristic method, it's a approximation method. It's approximates problem solving method, like Johnson's algorithm for flow shop scheduling. Then moving on to the main method, meta-heuristic, it is a complex problem solving method. Mainly it is inspired from nature, like biology, physics, sound-based laws, etc. Biology-based algorithm examples are differential evaluation method, genetic algorithm, then biography-based algorithm. According to physics-based algorithm, stimulated annealing, ray optimization, gravity search algorithm, and electromotive force algorithm. Then sound-based means particle optimization, whale optimization, and colony optimization, and gray wolf optimization. Moving on to the main whale optimization algorithm. It is a novel based algorithm, newly developed algorithm, Mirza-Lilly and Lewis in 2016. Whales are considered to be the biggest mammal in the world. They are mainly 7 species: killer whale, minke whale, sei whale, humpback whale, right whale, finback whale, and blue whale. Each of them have their own hunting characteristics. It is very interesting about hunting characteristics of humpback whales because they have a method of hunting is called a bubble net feeding method. Mirza-Lilly and Lewis developed a new algorithm based on this hunting technique. Moving on to the hunting technique. These whales only target group of fishes which are on the surface. When these fishes are in their sight, they moving downward up to 12 meters, then rise towards the prey by producing bubbles in spirally. So the fishes are trapped into the bubbles and they eat the fishes. This is the technique. Pictorial representation is there. And this technique is mathematically modeled to 3 steps: encircling the prey, which means the whale can see the prey, but here according to the algorithm we have not know the correct optimal solution, but the near solution, the correct near solution to the solution is prepared. WA assumes that the current best solution is, or current best candidate is the target prey. Then other whales are trying to move towards the best solution or the best search agent. This is the equation for this. D means distance between the solutions or difference between the solutions. And here data vectors, random numbers are there. Then second, bubble net attack. Then the prey is locked. They move towards the prey in two manner. Both have equal probability. That's the term includes P. Through spiral method of shrinking and circle mechanism. Following is the equation of both. This is the representation of pictorial representation. Then last step is search for prey. It is an exploration phase. Which means, is there any random solution which is best than our estimated best? According to the position of each other, Ampeg will search randomly and say a random solution is obtained. This is the equation similar to encircling, but X rand is inserted. In earlier, X best is inserted. This is the flow chart. Moving on to literature survey. The first literature is the way of optimization. This is the proposed algorithm is tested in benchmark problems and analyzed with other algorithms like PSO, differential evaluation, etc. In the literature, they said that it has a good rate of convergence and a rapid discovery solution. They are expecting to develop multi-objective and a discrete value optimization in future. Then Xiong in China allocated water resources by applying value optimization. In this paper, value optimization applied to optimal allocation of water in Xintai. The goal is maximum economic benefits. They analyzed each sector. They converted the water into domestic sector, private sector, etc. The results showed that total demand of water usage in Xintai is 26.94 into 10 meter cube. They allocated water in different sectors. Moving on to hybridization. Hybridization means modification or combination. Some of the researchers combined or modified the present algorithm for their problems, for corresponding problems. According to various researchers, the researchers said that the combining of this algorithm is incredibly comfortable. Value optimization can be hybridized with the other meta-heuristic algorithm as well as easy to modify. This modification is common nowadays. Then Ayan Trivedi, a novel hybrid particle sum value optimization algorithm is applied for global numerical function. Here, optimization is applied for exploration because it uses logarithmic spiral path, so that it in logarithmic spiral path most of the search space is covered. This paper optimization numerical functions are done. Algorithm, they said that algorithm gives better solution than other individual results. They compared it with different algorithms also. Yanhua Jia should use value optimization. Initially, the Midjourney and Lewis developed this algorithm for continuous problem like spring truss, but here he modified it to solve scheduling problem. Here the problem is converted to two subproblems like speed selection and a operation permutation. This is the string. This algorithm is coded in Fortran. Processing time is randomly generated. Then the sequence is randomly generated. This result is verified with a modified genetic algorithm and a teaching learning based algorithm and a Grave-Walls optimization algorithm. They have taken population size 200. The maximum iteration is taken as 1,500. To increase the solution quality, they applied a variable neighborhood search, and the result obtained are favorable for the researchers, and they are expecting to analyze the real world system in future. Falia also developed or modified the algorithm for solving scheduling problem. They converted the problem into machine assignment and operation assignment. Machine assignment means what is the machine used for the current operation. Here in the string we can say O11. O11 done by first thing is operation sequence. First is means O21 is the first operation. Then optimization is so etc. This is the flowchart of the current algorithm. This algorithm is evaluated using real-world system. A diamond, a researcher in China, studied a real-world system in Nanjing with 10 machine tools and 10 jobs with 32 operations. So that he developed an operation sequence or scheduled the sequence of with less make span using improved genetic algorithm. But by using the value optimization algorithm, I used the real-world system in my project. I reduced the make span by using the current algorithm, value optimization algorithm. Originally, the diamond obtained the result of 93 to 215 minute make span, but by using value optimization, I can reduce the make span range up to 121.3833 to 128.338 minutes. We got narrow range of make span, but diamond by using genetic algorithm, he got large, wide range of make span. This is the make span of iteration graph. In 42th iteration, we have got best solution. This is the diamond result. The maximum obtained is 215. But I got 128.33 minutes. Then in Singh and Achimi, you hybridized the algorithm with the gray wolf optimization. They also done it with exploitation because it is a spiral path. The solution obtained are better than the current algorithm. These are the literatures, other literatures I have studied for. Then value optimization, stimulated annealing is the value optimization, multiple flame optimization is there, particles optimization there. In many of them, result is better than original individual algorithm. Best result obtained by hybridizing it with the value optimization. Moving on to discussion. Hybridized or modified or combined algorithms are got better results than individual. This hybridization is increasing day by day. This algorithm, this combined algorithm, or this modified algorithm can solve complex problems that cannot be done by using individual algorithm. Value optimization initially developed to solve string problems, stress problem, like continuous problem, but after modification, it can be done to solve. It can be used to solve discrete problems. Hybridization can be increased. Hybridization helped to remove the individual limits like time duration, local convergence, etc. Value optimization became an important tool for optimization and other complicated problem solving, and like other meta heuristics. There is still room for still space for modification. Merits and demerits of value optimization. Conclusion. Moving on to conclusion. The demerits of value optimization, like origin is continuous problem, and premature convergence can be reduced by using hybridization or modification. Value optimization can be apply almost all areas like engineering, clustering, task scheduling, networking, etc. There is still space for value optimization algorithm to hybridize and modification. These are the references I studied. Sir, thank you. Hello.
Okay, Sarang, how many publications did you refer for your review?
30 plus.
30 books.
Mm.
Okay. You told hybridized algorithms can solve complex problems compared to if it is not combined. Okay. Can you elaborate on that, or some case study or some specific conditions can you tell wherein this will be very handy?
So value optimization is initially developed to solve problems like continuous, like spring stress. But after modification, it can be used for scheduling problem. In my project, I applied it to my project. In my project, I applied.
I couldn't hear you.
In my project, I applied the algorithm.
Okay.
Modified algorithm.
On that? Can you share that experience? What been?
I applied in a real world system. A paper is there. Diamine developed a paper using a real world system in Thai. According to this real world system, there are 10 machine tools with 10 jobs and 32 operations are there. So I scheduled it by using value optimization, and in the waste paper he scheduled the same problem using improved genetic algorithm. Both the result have differences because I can reduce it to 128.33 and the maximum extent he got is 215.33 minutes. So I got narrow range of result and he got wide range of result. So that I can say value optimization can be used. The modification can be used for scheduling and complex problems.
Okay. Thank you.
Sarang?
Sir.
So is there any specific method in which you select these reviews papers for this review? Any for a particular application or any such criteria in which you select that?
No, I just selected value optimization papers.
Actually, why I asked it is because your title is hybridization of value optimization, and the main part of your paper is basically on value optimization itself. That's why.
Sir, I think modification.
Hybridization.
Modification of value optimization.
Okay, for example, for a hybridization of value optimization, it will have been better if you compare different hybridization methods and their associated problems they solve.
So most of them hybridization technique, they applied it for exploration phase, value optimization equations. I just searched value optimization and hybridized algorithm for study and scheduling problems for my project also.
Your project, what is the application you are using it for your project? What is a real world? You told it's a real world application, right?
For job shop problems, for scheduling job shop, we can apply the value optimization for better results.
Is it hybridized value optimization?
It's a modification. Yeah.
Okay.
Initially, value optimization is done only for continuous problem like spring stress. It means to get a initial result with the value like 24.
No, in your problem, like, what is the modification you are making in your problem?
I just interchanged the steps, which means I just changed the step, which means some crossover are applied for each step. The newly developed algorithm is different from value optimization. Several modifications applied because initially I already told it used for continuous problem, which will give only a result, which means 65 MBA.
Okay, sir. Thank you.
I modified the result. I modified the algorithm with the crossovers, different crossovers, multi-point crossovers.
Okay, okay. Okay, sir. Thank you.
Thank you.
Okay, thank you, Sarang.
Any questions from audience? Okay, thank you, Sarang. Today's presentations are complete. And now,
Okay, thank you, Ashwin sir and other faculty members for giving me an opportunity to be here. Okay, wish all the students the very best. Thank you all.
Before winding up, once again, I would like to thank Professor Dr. Pradeep V and Professor Alishar Yogi for agreeing to be the chair of the session and joining us in time and completing the session well before the scheduled time. And now, I request both the chairs to give a feedback of the papers that were presented for the session. I request Dr. Pradeep V to start giving us the feedback.
Okay, all the presentations were from except 2-3. I think 2 to 3 papers were from the same domain. I think optimization. Another were from the materials, and one on fluid mechanics. The presentations were overall above average or good. No, nothing was not satisfactory. Everything was okay or above. And but looking at some of the papers, the manuscript, I think manuscripts need some modification within the content because maybe, as you referred, it is before review. The copy sent to me is the copy which was before review.
Yes, sir. The papers that was sent to you was before review.
Before review. Then I don't have that comment because I found some content-wise, grammar-wise, and all. Many papers need some modification or structure of the abstract and all. That was the thing. Presentations overall were very good, and I don't want to comment on a specific papers and all. And the slides were also good. But the review papers, I found maybe they can come out with they could have come out with some special case studies and come out with conclusions or recommendations on a particular method or procedure. Otherwise, I found all the papers are above average or good. And once again, thank you, Dr. AB, for inviting me. I think AB is back here, inviting me. Okay. And thank you, Arjun sir, Ashwin sir, Sudhish sir, and all. And my colleague Arun Shal sir is also there. Thank you. And students also. Wish you all the best.
Thank you, Pradeep sir, for your words. And basically, what had happened is three of out of the 5 papers that were presented, 4 from this GEC Kannur, and the 3, I think 3 of them were review papers. Actually, we couldn't give it. I mean, divide it into 2 sessions because the chairs for the yesterday's session was from GEC Kannur only. So that's why 3 to 4 review papers were on the session. So if we couldn't make any adjustments with that, so that was the problem. One problem that I have noticed. We will try to make it up in the next conference. Thank you, sir, Pradeep sir, and I would like to get the feedback from Professor Arun Shah. So Arun Shah, if you please.
No, there is nothing wrong in having review papers. I didn't mean that. Okay.
Hello. Okay. So first of all, I would like to thank you all for giving me this opportunity. Especially I thank Ebisa for inviting me for this, for being a chair for this conference. And regarding the presentations, this some of major most of these presentations were of this for shop scheduling and manufacturing side, and I'm not very well versed with that area. So my feedbacks and contribution may not be very very relevant to those others. But anyway, and one paper was on CFD, and one paper was on manufacturing. So when we consider the quality of a paper, all the papers and presentations were above average, and all the review papers, I have the same comment. I think the number of papers the authors have referred are not can be the number of papers can be improved, because considering the title of their papers, the actual content is not that inclusive in that paper. So that can be improved from for their future presentations. And apart from that, presentations as well as the overall organization of this conference was excellent. So once again, I would like to thank Ebisar, then Ashin sir, Arjun. He's my previous colleague also. So thank you, Arjun, and my our HOD sir also. Thank you all, and to all the students, all the researchers who have presented the papers in this conference. So one of the batch was my earlier students also. So thank you everyone once again.
Thank you, Arun Shah, and let me invite Dr. A.B. David to give the winding up comments on the session.
Thank you all. Particularly, I'm so happy that Vishal sir and Pradeep sir has agreed to chair this session, and the session has gone well, and most of the papers were presented in a beautiful way. Of course, shortcomings you have, Vishal sir has pointed out, and they are relevant. Relevant shortcomings has been pointed out. Actually, that is going to be encouraging for the students, so the students can make them better. And on behalf of the department, I would like to extend a warm thanks to both of you. So that you have attended this particular session and evaluated the papers. Thank you once again, and I also thank Sudesh sir for being the co-chair, and I thank Arvind sir as well as the session handler, Ashwin sir, for making this session a grand success. And from the side of the department, all thanks to all the participants for making this session. Making the session a grand one. Thank you all once again. Thank you, sir. And all.
Yeah, thank you. Thanks everyone once again, and I would like to inform to the participants that you may please join back for the validatory function at 2 o'clock, which will be hosted in the link that we have done for yesterday. Okay. Once again, thank you, and thank you everyone.
Thank you.